Hello, hello, hello. I'm Shalendra, and welcome to the Shelly Show, the AI Insight series of the Shelly Show. Hope you're doing well, and you're watching this simulcast live on LinkedIn, Twitter, Facebook, and YouTube. I hope you're safe and observing the protocols in your area regarding COVID, so that we keep each other healthy, safe, and secure. So these days, there's a lot of confusion around predictive analytics and machine learning. Every practitioner has a point of view on what is the difference between the two. So, and I too have a point of view as well. So I thought of bringing some um, practitioners together who are some senior leaders in this space and discuss the difference between predictive analytics and and machine learning with some examples. For you to view this episode and other sessions that are on emerging technologies live, I would request you to follow me so you can be heard, you can be alerted when a live session is on. This gives you an opportunity to directly ask the question from your guest. So please press the follow button on LinkedIn and Twitter and subscribe button on YouTube with the bell icon. If you're watching this now at the moment live, then please say hi to us so that I know there are people watching, and also which city are you joining us from, because most of the time I see a lot of audience coming from all over the world. So let us figure out where are people joining us from. So please let us know where are you joining us from in the comment section. Okay. Um, Today I have a giveaway as well. So I see every professional using LinkedIn, and we are live on LinkedIn as well. But they do not know how their LinkedIn profile projects to the world and what is missing in their profile. So here is an app that uses machine learning, available both on iOS and Android. So just download the app, and I will give you the link to the app. So this is the app. It's called Link Plus AI. You can download the app by just scanning this QR code, or you can just look for Link Plus AI. And then it's an invite only app, so you can use the invite code 611074, and you'll be allowed to get free access to understand how your LinkedIn profile actually performs. How is it projecting to the world? Have a look at the app. It uses machine learning. It uses AI at the back of it, and hopefully it will give you some understanding of how your LinkedIn profile projects to the world. Okay, coming back to our guests. But before the guests, if you've got any question as you go through, please put those questions in the comment section, and I'll take those questions in the audience Q&A section. Guest. My first guest is Sanjay Sharma, who is the managing director at Accenture and was my partner in crime when I was driving analytics in ANZ. He's been consulting on marketing strategy and tactics using advanced quantitative solutions, platform development for delivery of marketing services, CRM, and customer infused marketing. I always fumble that. But anyways, he's been a great data scientist all his life. He's done some great stuff, and I think because he's established best in class capability in data driven consulting, including, of course, predictive analytics and machine learning, I thought, who else than to ask Sanjay about what is the difference between predictive analytics and machine learning. So I've got Sanjay. So let me, without any further ado, bring in Sanjay. Hi, Sanjay. Welcome to the
Hi.
Shelly Show. How are you doing?
Good, good, very good. Good to see you.
Good stuff, Sanjay. Sanjay, so very quickly, tell us about one fun fact about yourself, which not many people know.
Everybody knows that I'm bald. Unfortunately, I cannot hide it.
And tell us something that people don't know.
Well, again, associated with my baldness, right? The first time I got to know that I'm getting bald was when I was in college, where another student who was 2 years senior to me called me, Uncle, what's the time?
Oh, until what's the time? That was a good one. Okay, very quickly, let me bring in the other guests, and then we will start the conversation as we always do. My second guest is also from Accenture, and her name is Mamta Rajnayak. With more than 15 years of experience, Mamta Aggarwal Rajnayak is managing director at Global AI Hub, Accenture India. leading and managing retail analytics practice for her global clients. She works with the community of enthusiasts and talented machine learning engineers, data scientists, and data engineers who leverage industry leading technologies such as AI and machine learning. She's been featured on 40 Under 40 Data Scientists 2022 list by AIM, run by Bhaskar, as we all know him. Three AI Presidents Honor 2022, the AI Maker 153I 2021. So she's got a lot of awards. So let's just get her in and ask her about it. Um, Hi Mamta, thank you for
Hi,
coming to the show. How are you doing?
I'm great. Thank you for having me here, Shailendra. Lovely to be a part of it.
Good stuff. Thank you. You know, I was talking to guys. I was talking to Mamta yesterday. So actually, when I left Accenture, was the time she joined Accenture. So we never actually had an overlap. So you know, she picked up from after I left. So let us ask her. Tell us one fun fact about yourself, Mamta.
Fun fact about me. So I love mathematics since my childhood, but one subject which I hated always was social studies. And the fun fact is, these days I am the social studies tutor for my son.
That's a good one. But social studies has an important role to play in what we all do, anyways. So and that comes to the fact, and I used to laugh around with Sanjay at point in time that all those people who actually skipped the stats chapter in their 10th class aspire to become a data scientist now. So it's a funny story. Anyways, let's get our next guest all the way from US. My third guest is Eric Siegel from California. Eric Siegel is a leading consultant and former Columbia University professor who makes machine learning understandable and captivating. He's the founder of Predictive Analytics World and Deep Learning World conference series, which have served more than 17,000 attendees since 2009. So many people have attended his show, his conference. The instructor of the acclaimed online course, Machine Learning Leadership and Practice, End-to-End Mastery. He's a popular speaker who's been commissioned for more than 110 keynote addresses and executive editor of the Machine Learning Time. He is absolutely very popular. He's also authored the book Predictive Analytics: The Power to Predict Who Will Click, Buy, Lie, or Die. A very long name. We will talk about that with him. So you've got two best-selling authors on this show. Good stuff. Let's get him in. Hi, Eric. How
Hey
are you
there.
doing?
Good, Shalendra. Thanks for having me.
Good stuff. Welcome to the show.
Thank you very much. So I'm ready. I'm ready for the question. You know, I got to go last, so I got time to think about it.
Okay, so tell us one fun fact about you.
Is anybody listening to this, or is just between us?
No,
So
there are
I'll do
lots of
anything.
people listening.
I'll do anything to educate on predictive analytics and machine learning. So I actually released an educational rap music video called Predict This about predictive analytics. It's a goofy video, but the lyrics are substantive and tell you everything you want to know about predictive analytics. And you can find it. It's just 3 minutes and 20 seconds long. Or 40 seconds. You can find it at predictthis.org, and it's on YouTube.
It would be a great idea if you could post that onto the comments so people can actually watch it. It's
Yeah,
brilliant actually.
gladly.
Good stuff. Okay, let's run through the question. So the idea behind this particular show was the confusion that is there in the market. What is predictive analytics and what is machine learning? Everyone has their own view. Everyone has their own definition. So I thought you guys are the experts, and why not ask you guys? So let me start with the lady first in the room, Mamta. What do you think? What is the difference between predictive analytics and machine learning?
Okay, thanks, Shailendra. So, see, when you talk about machine learning is nothing but a discipline which uses mathematical models to help you do something, right? Which means that you may be doing supervised learning, unsupervised learning, or anything of that sort, right? When you talk about predictive analytics, it's mainly about supervised learning, wherein you are basically trying to predict something looking at the past behavior, right? So, in a way, predictive analytics is a subset of machine learning in my understanding.
Okay. Predictive analytics is a subset of machine learning. Okay. Sanjay, what do you think?
In my view, predictive analytics, when we are talking about, it's how you are going to use it, the objective, right? And machine learning is a broad framework. How you are computing, how you are assessing the data, how you are manipulating the data, how you are developing the algorithm, how you are evaluating the algorithm, and then it depends how you are using. Incidentally, almost all machine learning is used in predictive, right? Machine learning, there are certain twists when you use it for, for explanatory analysis, but it lends very easily to predictive. And that's why perhaps people are getting confused. But machine learning is a broader framework. It's a one way of methodology or a framework of computing.
Okay. Eric, what do you think?
I think that those answers were consistent. I'll agree. I agree with both of them, and I'll get a little more specific. Predictive analytics is a subset. Oftentimes, it's synonymous with machine learning, but really, it's It's a large subset of business applications of machine learning. Um, Typically, things where you're predicting, is this going to turn out to be fraudulent? Is this credit applicant going to turn out to be a good credit applicant? Is this customer going to respond to this marketing? So those kinds of business applications. Whereas deep learning, which now is really the hottest advanced form of machine learning, has taken hold. Most of the applications in that area where you're saying, hey, is there a traffic light in this? Is this a picture of a cat or a dog? Is there a traffic light in this image? Speech recognition. Those applications that tend to be where you apply deep learning, although that's not an absolute, but that just happens to be the kinds of places where people probably would not use the term predictive analytics for those kinds of applications. Ironically, though, even within the business applications that you do call predictive, that's where some people get semantically opposed to using the word predict, because if you're trying to detect which transactions are fraudulent, or you're trying to detect whether a medical tests confer a certain diagnosis, you're predicting the diagnosis, you're predicting the classification. So, but I think that's okay. That's still called predictive analytics, and either way, you're trying to ascertain an unknown, and yeah, you're trying to predict, is this fraud? You're not predicting the future, but people do use the word, so it is predictive analytics. There's other machine learning applications, typically large signal processing like you do with deep learning. People tend to not use the term predictive analytics.
Okay. I would go with my personal view is that what Mamta said, that machine learning, sorry, predictive analytics is a subset of machine learning. I think machine learning revolves around what we've been doing over the years, Sanjay, as you would imagine, writing all the code for all the doing all the prediction, writing all the statistical models in order to predict something, and the framework around that, getting the data, optimizing it, making sure that is running it, in a fashion that you're able to automate that whole process is machine learning. And that's my view. And as we said, everyone has a different view, and we're trying to just nail that down. So, Mamta, I'll come back to you to say any use case that you see glaring at you, differentiating the two, that makes it much more simpler to understand. Um,
Sure.
Go on.
See, machine learning, when you talk about machine learning, it's all about if you can let the machine do the job themselves, right? That's where, and you leverage a lot of mathematical models to do that, right? When you're talking about predictive analytics, it's mainly, like I said earlier, it's mainly about looking at the past behavior, then coming up with a prediction. For example, forecasting, right? That's an example of predictive modeling. Or classification, that's an example of predictive modeling. When I'm saying classification, whether a customer would do a fraud or not in a banking scenario, or if, because I come from retail, I've been doing a lot of marketing analytics. I would say whether a customer is going to buy something from my retail store or not, right? That is what falls into a classification model. So both of these are predictive analytics, and machine learning can solve both of them. Whereas there are other things like, let's say, customer segmentation, clustering. Those are also other disciplines in machine learning, but they are not predicting anything. What you're trying to do is basically you're trying to classify your customers in terms of, it's not something which is governed by, something which the machine would be able to say that, oh, I want to do something like this, but what the machine is doing is it is trying to look at the overall behavior of the customer and then trying to put them into the group. So there is no, in a way, something to guide the machine. The machine is trying to figure out on its own. Whereas in predictive analytics, there is something which the machine would learn from, look at if the customer did the fraud in past or not, right? And hence the another customer or the same customer has a probability to do fraud in future or not, right? That is prediction. But classification, the clustering is different, because that's where you're not predicting, you're actually just in a way grouping similar customers together. So that's where I would say a little bit of a difference I can try to explain.
Okay. Eric, what do you think? Any use case? You mentioned a couple of them around fraud and the others. Anything that clearly explains the difference between machine learning and predictive analytics?
Sure. I mean, well, first of all, I agree with what Mamta just said, which, basically not just that predictive analytics is a subset of machine learning, but more specifically, it's a subset of supervised machine learning.
Mm.
And but just because it's supervised, it's not always called predictive analytics. So again, I think some of these sort of signal processing type of applications that tend to be where you're applying deep learning, such as for speech recognition and image processing, people and other kind of industrial applications, some of them in industry, people tend to not call those things predictive analytics. It's a little bit of a fuzzy area, but it tends to be more kind of typical corporate enterprise business applications of machine learning, right? So we've got fraud detection, credit scoring, targeting of marketing, website behavior, on targeting of online ads. But then outside of that, I mean, there's parts of healthcare applications and even political campaigns trying to target which voters you're most likely to be able to persuade to vote for your candidate, which is obviously just another kind of marketing application. These places people are calling it predictive analytics, or they're just calling it machine learning. I mean, if you're not sure, you can always just if predictive analytics is a subset, then just and you're not sure, you can always be safe by just calling it machine learning.
Yeah, exactly. Sanjay, what do you think?
Okay, let me. It's a continuum, Shalin. I again keep on saying that. We consultant need something new to sell. Right? So we keep on inventing. When I started my career, 20 years, 25, whenever, beyond 20 years, you stop counting. I was marketing credit cards. For that, I was predicting your probability whether you'll respond it or not, right? So that's a predicting, right? And I was doing the raw logistic, logit, probit, all those models with several specification and choosing which model to choose. And I was figuring out which variable to use and how do I transform, etc., etc. But that was predictive analysis, isn't it? But it was not machine learning. Now things have changed. Computing power has changed. World has changed. So I put tons of data to the computer, use that Bluetooth computing force to slice and dice data, which we call it feature engineering. Then I say, okay, you develop models. And why one model? Develop the whole forest of models, right? So not one tree, create the whole forest, and we call it machine learning. So again, I would say, from business perspective, you are doing the same thing, but tools and techniques and wherewithals available to you have changed. And this new name is not so new name is machine learning. Actually, you withdrew one angle of the confusion, and that is AI. So many people use AI also over here.
Yeah, I've been
But
waiting for somebody to bring that up.
Yeah.
no, in fact, I had a big debate at AI, kind of a startup awards, and I was told that they run AI algorithm, and I didn't know what it was. So I had to ask them what it is, and turned out it was a statistical model that they were building, selling as AI algorithm. So there is a lot of new terms that have been thrown out in the market, and I think I totally agree with you, Sanjay. I think there is a bit of the fact that when we get bored with one particular terminology, we start a new terminology altogether. I used to say a lot when we couldn't sell data warehouses anymore, we created big data, and when we couldn't sell big data anymore, we thought what to do next, and then it became data, whatever, data marts, data all of those little things that
Data lake, data
data
swamp,
lake
whatever you
and
call it.
what not. At the end of the day, it was doing the same old thing, right? So when we struggle in when we're not able to sell something, we create a new terminology, and I think this is also one of the use cases there. Eric, you mentioned about supervised learning, but before I go there, guys, I can see around about 50 people, 50, 55 people watching this. It won't harm if you just press the like button on a thumb or a heart button wherever you're watching. Please do that. It means a lot. So please like, share, and love whatever you want to do on whichever platform you're watching this. Before I go to Eric, the other thing which I want to say is, guys, please, if you've got a question, if you've got any confusion, just put that in the comment section, and I will take that in the audience Q&A. Coming to you, Eric. I was talking about you mentioned about supervised learning. So let's talk about what is the difference between supervised and unsupervised learning in the machine learning context. Because we're going there, so let's discuss that in details as well, if possible, with
Sure.
examples.
Well, I was just repeating what Mamta had said, which I was agreeing with. She brought up supervised learning and versus unsupervised. Um, supervised learning is where there's uh, an objective, where there's an actual target you're trying to match, and therefore you can measure how well the result of learning works. That's very helpful. Whereas unsupervised learning is more of a subjective, throw the data at the algorithm, and it just tries to figure out, well, how do these things kind of group or cluster into naturally occurring, potentially meaningful clusters, and then you as a human look at the result and try to interpret it and determine whether it might be insightful or inspiring some ideas of how to market to these segments of customers or whatever it is your domain is. Whereas supervised is if you have existing data where you already know the correct answer. So it's labeled, maybe it's labeled manually by a human. This is a cat, this is a dog. But in many of these business applications, in the majority of business applications where you would actually use the term predictive analytics, in fact, it's what's called found data. It wasn't derived by human labelers, and it was not derived by experimentation, but it's just the side effect of doing business as usual, where history has spoken. You found out, hey, this customer did cancel. This customer did respond to this marketing. This transaction did turn out to be fraudulent. Um, this credit, this debtor turned out to be a bad debtor and defaulted on their payment. So whether they're positive or negative outcomes, history has spoken, and that's where you have the source for many examples of the correct answer. And when you have the correct answer, you can apply supervised learning, where those correct answers serve not only to guide the learning process and to develop the model that's going to try to make predictions on those types of answers for new cases, but they also serve to evaluate how well that model works in a held aside test set. So that's where you get to actually measure um, how well the machine learning works. It's a much more comfortable place to be if indeed you do have that data. And in fact, this history speaking thing is there's sort of an automatic availability of exactly the data that you want, in a sense that tends to be the case. The operations that you conduct most frequently every day as an organization for marketing decisions, credit decisions, all of these micro decisions on, let's say, often on a per customer basis, those things you're doing the most of, you have the most data about. And those are exactly the kinds of things where it would pay the most to optimize the performance and improve all those micro decisions. So we organically already have the historical data, and therefore the data that's labeled in that sense, over which to apply supervised machine learning.
Mhm. Sanjay, what do you think?
Yeah, actually, here again, I think that many times we are trying to find a very forcing some differentiation. So, if you again see this as a continuum and two extremes, yes, you will find this is one way is completely supervised, and other way is clustering, as Mamta said, that is completely unsupervised. I do not know what this data is, what are the hidden patterns in that, proximity of the behavior, etc., etc. So I want to know, so I throw it to the machine and ask machine to tell me what's going on, right? And they tell me that, okay, these are the guys who behave in a certain way, those are the guys who behave or misbehave or whatever you call it, right? And that's my new understanding, new knowledge. I have not guided it anything. So it's just this one extreme. The other extreme is I know which kind of guy I want to sell my product, and I know these are high income guys who are most likely to buy, etc., whatever. And I have an objective that I want you to buy this, so I'm looking at that level. So that becomes, that end becomes supervised, right? But again, it's a continuum. The most common clustering in machine learning itself is k means,
Yep.
and in k means you tell the system how many clusters you want to make. Tell me, is it supervised or unsupervised? How do I know that it needs to have four cluster and not six? Actually, it's a mix of both. I try four and I try to
Yeah.
validate. I'm not happy. Then I try six. Then I try
Six. Yeah.
two and I try five, etc., etc. You got my point. So again, for the learner and a practitioner, we have to take a step back and again focus ourselves on the business. What do we want to do? What are we going to gain or learn out of it? And then apply whatever you want to. So maybe you will apply unsupervised, have some good understanding, and try push it into your supervised one. And I can give you one very funny example from my own life, right? So in a very short run means less than a year, typically your marketing, whatever you're doing in marketing, is going to have an impact on your sales,
Yep.
right? And when we were transitioning from the legacy analytics to the machine learning approach, right? So unsupervised is very glamorous. You put stuff to it and it'll give it you back, and we dump all the data and ask the machine to give us the result, and the result was other way around, that your sales is causing your marketing. Whereas marketing is my policy variable in short term, right? I do not want this as a something dependent. I want this to use to cause something, right? So we went back and created some white leads, blacklist in that. Okay, the relationship will go this way or that way. So I mean, blind application doesn't work. You need to understand the business problem and then figure out within this whole repertoire which tune is going to suit best.
No, absolutely. I think most of the people would understand that you need to start from the business problem that you're trying to solve. And 90%, and we'll come to that as a question again, but I've seen 90% of the people actually say, give me the data and I'll tell you something, which is a very wrong approach because you don't have any direction, but you're trying to run. And I don't know, that may be a good idea at a point in time, but not always. Okay, Mamta, before I come to you, guys, questions, put that in the comment section. Mamta, what do you think? And you actually started the debate around supervised and unsupervised. So differentiate it, and if you can explain with a use case, great.
Sure, Shailendra. In fact, both Eric and Sanjay have explained it in great detail. So I wanted to actually, talk about one, of course, the, supervised and unsupervised learning and what's the difference. But at the same time, machine learning, when we talk about machine learning versus predictive learning, there are still some areas where people feel that the traditional way of doing predictive analytics is much more effective because you are getting to know what exactly is there in the model, whereas machine learning, people feel that it's a black box. Of course, earlier, if I were to do a supervised learning in terms of doing a classification model, right, I would use a single decision tree. Whereas, like Sanjay mentioned, right, random forest, we are building hundreds and thousands of trees and then using ensembling of all of that to come up with one single score for the customer, right? Which means that looking at those thousand trees, then I will have to explain what are those factors which are important, right, for my model, right? Because if I'm doing a business, then I would want to know if a customer has a propensity to perform a fraud, or if a customer has a propensity to buy a particular product from me, then what are those forces which are driving that, right? It was very easy for our traditional predictive analytics models to tell us what are those key features which are impacting it. But in machine learning, it was becoming difficult, at least initially, because we all were new to it. We did not know how to really interpret those models, and that's where the entire explainability of the models is coming into the picture these days, right? All those shapely values, lime, and those kind of things, right? That is helping us do that. In terms of unsupervised learning, there is still not, I would say, lot to be developed, right? Predictive analytics in machine learning has still concretized a bit more as of now. whereas unsupervised learning is still developing. We are doing a lot, right? Now there are areas, for example, the video analytics, the image analytics, which is again, as Sanjay says, right, a mix of both predictive, unsupervised and supervised modeling, whereas we know what to predict to a certain extent, right, whether it's a cat or a dog in image analytics, but so many times we don't even know what it is, right? So it is also using unsupervised learning. So a lot then goes into, yes, I'm going to use supervised learning, I'm going to use unsupervised learning based on my business requirement. But now, once I've started using machine learning, which is efficient, which is more robust, but then am I actually making sense of these models?
Before I get to the next question, I can ask all three of you: is there any use case from either predictive or machine learning that has actually blown your mind away and said, oh, "Yeah, I never thought about this." Something that has actually changed your thought process, or something that has actually made a huge difference. Uh, not necessarily monetarily, but a difference. Any use case that comes to mind? Anyone?
Maybe let me take a pick on that,
Okay.
Shalindra. See, actually, there are lots, right? We are doing so much in medical diagnostic, right? Cancers are getting detected using image analytics, etc. But one of the things which really excited me, and I really felt for it, is when one of our colleague in US, Accenture US, he and his team created, using data analytics, he created an algorithm which can help us actually predict human trafficking, right, where the human trafficking is going to happen. So that is exciting, right? With the power of data, with the power of models, if you're able to predict where these heinous crimes are going to happen, that's really inspiring. Me and my team, we also built a we also filed a patent wherein the models developed by us can help us predicting the illicit behavior, human behavior, which includes fraud or crime and things like that. So those are some of the examples which makes me feel that, yeah, we are not only helping our businesses, but we can also do a lot to the society as well through predictive analytics, machine learning.
Eric?
Yeah, I mean, in fraud detection, there's a lot of value there. One of the most exciting case studies I've heard about is UPS, United Parcel Service in the U.S. It's one of the main delivery services alongside Federal Express in the United States government postal service, and they've decreased the required driving by tens of millions of miles a year. Um, uh, Partly by using predictive analytics to predict every day's deliveries, because they have to start loading the trucks and according to a way that'll optimize deliveries for each region before they know all the deliveries they're going to have to do that day. So they literally predict address and start planning basically for deliveries that they don't necessarily know are going to happen. So I'm very excited about the science side, but the business cases where there's actually value, where you're making use of this technology and it actually gets deployed and makes a difference in the large scale operations, those are relatively few and far between. And so I'd like to. I've been leading every time I get to open my mouth, not so much today, but as much as I can, I've been leading with that theme of the business case that you all have mentioned a bit here and there, as the thing that I think most data scientists certainly understand the fundamentals, but it's not widely understood the degree to which you need to really forge and plan for a path to operational deployment, to actually implementing and deploying that model so that its predictions actually improve and make a change to the largest operations of the organization where it can really make a difference. That's a change management problem, and most modeling projects fail. We're seeing that with polls, including a poll that I conducted with Katie Nuggets recently, and the results show that most data scientists say that only 0 to 10% of the models that they generate with the intention of deployment actually achieve deployment. So there's a lot of stalling of projects, and it's and I believe it's because of the lack of the right leadership practice that gets you to the end there. That not just sort of generally plans, hey, we're going to use this and change the way we assign tasks to our fraud auditors. So you've got a team of auditors are looking at transactions, which one might be fraudulent. Um, how do you decide which transactions they look at? Well, a model is going to make that better. But if it hasn't been done with a model, that's kind of a big change to operations. And by the time the modeling's done, the people in charge, the line of business operations, the auditors themselves, they might not really have got it as much as they need to before they're ready to greenlight the deployment. So the lack of deployment is a major issue. The business value is understood but not achieved in many projects.
No, I totally agree with you, and I think Sanjay would even second me and say, anytime when we do a analytics or a machine learning project, the first thing is to make sure that you've got the buy-in of the business, because you can build, and one of my PhDs used to tell me, I can build a very good model, Shelley, but if it is not executed, it's good for nothing. So you need to be very, very sure that there is a user at the end who's going to actually take it to market to execute it. Sanjay?
Yes, you are right. And actually, a step further, now when we are living in a machine learning world, we want to automate the process and industrialize the process. So not only I made a model for predicting something, it should be refreshed, preferably real time, should have the same kind of efficiency and dependability which my handcrafted model was or the original model was. And the seamlessly all these scores should be estimated and the score should go into execution, the execution part which Eric was mentioning. So most of the work is happening actually in this space. How do I take my model to a level where I can trust the whole process, that will be refreshed and that refresh would be equally dependable or reasonably dependable, and then it goes into that execution process. And actually that has opened new doors for application. For example, dynamic pricing for e-retailing, dynamic pricing for you know to some extent hotels are already doing it, but other retails, hotels and airlines is doing it, but other retail and other people have started doing it. How much inventory do I have, what demand do I expect during next fortnight or next week, etc., etc. Given that, what action I take that I get whole of it, and putting all of that into a process and getting it. But again, getting a buy-in for the business is little longer over there, right? I had my own share of difficulties over there, where you know merchandising manager said, okay, you asked me to be accountable for revenue, you asked me to be accountable for profit, but you asked me to blindly trust this equation which this guy is saying. Give those targets to him, I'm not responsible. So obviously, those fine tuning within the org constructs which is going to support all this kind of thing will take some time, but this is a work in progress as we speak.
Okay. Sanjay, you mentioned about that a lot of automation is going on at this place. I would like to know what are the challenges, some key challenges in moving this whole experimentation into production. When it gets into production, what are the challenges that you see? While you're taking it to market, automating, setting, forgetting kind of stuff.
Actually, the whole construct of the problem as well as the solution. So what is my baseline? How do I estimate what is that data? And in many cases that data is not that easily estimatable, right? Then do you want to run a parallel testing somewhere, A B testing, or you know multi-factor testing kind of a thing? How do you loop in? How do you decide whether this is good enough or not? And how do you get the business to sign it off, right? These are some of the broader challenges. Then there are challenges in terms of skill and manpower, the people who can really put this machine learning models into machine learning operation, right? That's a skill which is not very easily available. You need a data scientist who has become an engineer, right? And data scientists love to remain a data scientist.
Yeah, yeah, yeah.
And there's a little bit of divide between engineering and then the data scientist guy. So I think that is taking little bit of time, and it will come in full force as the market matures. I think it's more of a maturity issue than anything else.
Mamta, what do you think?
Yeah, no, I totally agree with Sanjay. See, talent is very, very important. in this, because so far as data scientists, and as it is widely known, right, 80% of the models that the data scientists build so far has not been going into production, right? Which means that it's only 20% of the work that all the work that we are doing has actually been getting used. And imagine the amount of impact it will have if you're able to create this entire 100% of the work that we're doing into productionized models. Now, in order to do that, one, of course, we need to have the right infrastructure into the place. And that's where cloud computing and all of that is coming into the picture, which is enabling all of this, right? Second is the talent, which Sanjay mentioned, right? It is extremely important that we are cross training our data scientists into data engineers and vice versa, right? Because those and see, while data science brings in the right creativity and the right science knowledge, the data engineering brings in the right discipline, right? And the processes to it. So a combination of it is what is going to make things happen, right? And because of this, there are newer roles are emerging. For example, ML engineers, right? That is something which we started hearing about a year or two back, and now there are more newer roles are getting created. For example, ML testers, right? These are the kind of roles which we had not heard before. In fact, like Sanjay mentioned, there is a kind of a divide between data scientists and data engineers. Data scientists would always feel that their work is more superior, whereas data engineers would feel that they are more niche, right? And they both don't want to do each other's work. In fact, at times there's a slight aspiration within data engineers to become data scientists, but I want to see that aspiration among our data scientists also to become engineers, because we need that mindset now, right? And that is why my actually message to all the existing data scientists and aspiring data scientists to not see data science or ML as only a machine learning development work. If you think about the amount of work that is done in order to come up with a strong machine learning model, 85%, 80 to 85% of it is actually data preparation. And if
Yep.
you do your data preparation right, you will actually be able to come up with a very strong model. And then also they should not forget about the storytelling around it, right? If you're not able to explain your models the way the passion that you put in developing the model, if you're not able to really put it into the real business, in a business story, then you are not going to get that buying from your stakeholders, and hence the model will not get implemented, right? So 80%, 80 to 85% data preparation, just 10% is that model building and all of this machine learning, and then the storytelling, visualization, and all of that, right? So all of these skills are very, very important, and all our data scientists should not undermine the importance of all of these aspects.
Eric, what do you think?
That sounds spot on. What Mamta just said. I was just writing it down because I think the way she put it is so good. I was thinking of emailing her to see if I can quote her, try to rephrase or get the wording in a way that she'd approve. I mean, that whole um, point that if we're what we're concerned about is deployment, it really starts back with that data preparation. And the other thing is that this whole idea of having the business concept speaks directly to data preparation, the business value, because it's the dependent variable in the data, the thing that you're predicting, that you're modeling on. That has to be defined and determined with business considerations. So it's a very specific thing that it's almost a semi-technical thing that needs to be determined, but with business side consent. And that directly is then manifested only by way of the data preparation. That's where you're determining what it is you're predicting in the first place. And on the side of this sort of being business oriented and working harder, I think, as we all must, to get these projects on track towards better success rates of real deployment. Shalendra, you said a minute ago something. You said the first thing you need to have the mind of the business, I think is what you said. But I wanted to check. Did you say the mind of the business? The first thing you need is the mind of the business? Is
You
that
need to get the business objective right. You need to
yeah,
get the business buy-in. Who's going to
right.
execute that?
Yeah. Well, but I thought you said the word mind, as if you need to, as a data scientist, you have to have the business mind, or maybe you meant you have to somehow tap into the
No,
minds of the business
that
people.
is also there. As a data
Yeah.
scientist, your business knowledge has to be there. It's a domain expertise that you need to have. Otherwise, you will build something looking at the data and looking at the technology and everything, and you will land up in a situation where that was done deliberately by the business to gain more business or something else. So you
Hmm.
need to be having that mindset of
Hmm. Hmm.
running a business as a businessman, and that is very, very important.
So I could connect the original question that you asked us at the beginning of this episode to what we're talking about now, right? We're talking about what's the business value and how do you frame it and sell it internally so that it actually gets deployed. Well, predictive analytics, is used more for business applications as a term rather than machine learning, and maybe appropriately so, because predictive analytics talks about the thing that gets output, the predictions, the things that are actually valuable. Whereas machine learning alludes to the way that model is generated, the technology that's the means to the end. The end are the predictions. The means to the end is the learning, the actual analysis, the number crunching part. And that's the rocket science. That's the part that's fun. But being so enamored with that rocket science, with that number crunching, is kind of like being so excited about building a rocket. Whereas if we all know it's the launch of the rocket that's the real event and focus of rocket science.
No, I'll take it a bit further. Actually, you've actually nailed it, and I've been saying that for a while, but I was not finding the right way of explaining it today because maybe I just didn't wake up on the right side of the bed today. But but you're absolutely right. We build, and then let's bring it to life. We build predictive models manually to see what is the output, and then and then we talk to the business, understand the outcome, build the model, create the output, and execute it. Whereas in machine learning, we use the same model to automate it right from getting the data to making sure that the model is running and refreshing by itself and running it through. I think that is where the differentiation between predictive analytics and machine learning comes into play. Because predictive analytics or the components of machine learning, which people talk about ML model and all that stuff, have been there for ages, right? Sanjay and I would say that we were doing neural network models way back in 1995, 96. So what is new? It's like, using that in, because the machines have become powerful, there is more memory to actually run that through. So, you're able to automate those processes. So I think that is, for me, is machine learning. But you'll have to build a model at least once in order to be automated in the other sense. Does that make sense, guys? Eric, do you believe the same?
Most, I think most of what you said, I got a little lost at the end there. Yeah, I mean, I think that you are the odd person out here, right? The three of us, I think, kind of agreed of the hierarchy. Machine learning is the umbrella, and then predictive analytics is and you had this other thing. I mean, this is just semantics, right? Arose by any other name.
Yeah.
Terminology is fine as long as you're clear on what you mean by it. Except for the term AI, I'm just against that word. I just
So
have to
I'm not
say
even
it.
using. So see, in the whole process, we didn't use that term at all. And
I
so
know. I'm sorry.
and and no, but that's true. I don't. In fact, I'll tell you a very good story. I went to Taipei and I went to see the first bank, the CIO of First Bank, and I flew all the way from Sydney to Taipei, 8-hour flight. We shook hands, and the first thing he told me was, "Shelly, I don't believe in AI." So my meeting was over before even it started. So I said, hang on a minute, I also don't believe in AI. It's two to tango. Let's start. So I took him on a journey from statistical modeling to predictive analytics to machine learning, and then possibly we'll talk about AI in a sense. And I think people miss that, and they jump onto AI, and the names have been floating around, right? AI algorithm, ML algorithm, statistical model, predictive analytics model. I don't know, are they not the same? I don't know. But that's what has been happening. Okay, very quickly, I'm conscious of time. Let's very quickly run through our to the last question that I had in my mind. So machine learning projects, they succeed and they fail. What are the main reasons you see for a machine learning project to fail? And before you go into the answering those questions, guys, anyone who's watching this, if you've got a question, put that in the comment section. I'll take that in just a couple of minutes after this question. I'll take that to the audience, to my panelists. So please, 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 if you've got a question, put that in the comment section and don't forget to like this video with as many people as possible. So now, Mamta, I'll come to you. What do you see machine? Why do you see machine learning projects failing? What are the reasons behind failure of machine learning projects?
Actually, there are lots and lots of things which can make a machine learning model fail, right? To start with, if let's say, first of all, we the objective, and most of the time, the businesses nowadays get carried away, and they just want to apply AI and ML in their business, right? Because it sounds cool, right? So if that is the objective with which they start, you will certainly fail, because in order to do any model which can help your business, you need to have that clear objective in your mind, why you want to do it, how is it going to help you take better decisions. That's one thing, very very important. Second thing is, junk in, junk out. If your data is not sorted properly, if you've not done enough to sort out the data, if you've not formulated the problem well, then whatever you're going to produce is not going to be of any help, and hence will be a failure, right? Third thing is also willingness to implement them, right? You've spent a lot of money getting the model developed, you like the result, everything is happening, but there is internal politics between the analytics team and the strategy team and the IT team in your own organization, because of which you're either not able to implement it or you don't have the willingness to implement it. That is also a lot of time leads to this kind of failures. So those 3 pointers, if you're able to solve those three, get them sorted, I think any machine learning model which is robust enough will always have a place to add value to your business.
Eric?
Well, I'll as a joke, I'll disagree with Mamta in that if your objective is to look cool and sound cool because you're doing machine learning, then you'll succeed because you are cool. It does seem cool. It's the coolest technology. But yeah, I mean that's the wild thing is that as advanced as this technology is, it's not a technical pitfall that tends to be the thing leading to failure. It's organizational pitfall of not properly planning and forging a path to deployment, an organizational process. So that's the thing is that machine learning, yes, it's the most advanced, important, potent technology, period. But a machine learning project should not be conceived as a technical project. It is an organizational project to improve operations that has a technical component. So what we're talking about here is, the upgrade of an organization is to apply probabilities, is to act probabilistically on a micro level across many millions of decisions and use probabilities. Um, and machine learning is a probability calculator. So the only problem with that pitch is that it doesn't sound as sexy. Um,
Yeah.
but uh, at least it's valuable. Does that mean anything? I mean, and the other thing is that even if you get that concrete and you say, it's just a bunch of probabilities, and then people their eyes start to glaze over and they're going to sleep and they're like, that doesn't sound exciting. Where's all the AI stuff? But then all you
Yeah.
have to do is say, hey, wait a minute. GPT-3 generates language that looks like a human wrote it by probabilistically predicting one word at a time. And it looks at what's been written so far, what's the next most probable word across all human writing. And by doing it that little prediction, one word at a time, you're writing coherent sentences and paragraphs. So probabilities are a lot more than just a number.
Okay, Sanjay, what do you think?
I
Why
think this has been summarized very well by my two fellow speakers. Very, very well, actually. Yes, you need to figure out what's your objective. If the objective is to show a new shining toy, then have this toy, have a good fun, play with it. Don't expect it is going to change. And at times in life, you need that, right? I join your company, Shailin, and I say, Shailin, I'm doing exactly the same thing which the previous guy was doing with 10% or 15% more money, you will say, why do I need you? So I have to tell you that I have a new toy and will do something great, etc., etc. If that's a place, that's the objective, let it be. But if that's not the objective, figure out the objective, what you want to do, then choose what you want to choose. It's a one time machine learning thing or one time model, or it's a model in production. The production is by human or the production is by machine, right? And what you want to do it? You want to predict or you want to explain, right? Many times they said, okay, create a model, program for forecasting and then explain me. And at times this could be at loggerheads, or develop an explanatory model. That happens quite a lot in marketing, right? What is causing my sales to move up and what is causing my cannibalization if it is happening, etc. And then suddenly, if you trust your model, use it for forecasting. Now, deep in our heart, we know that a model is developed for a particular objective or purpose, and its efficacy will reduce if you start using it some other places, right? But if you start using this as a Midas stone and touch and convert everything in gold, that becomes very difficult. And understand the psychology of a data scientist. As a statistician and a data scientist, I do not want to say my model sucks. So in a nicer language, I'll try to explain you that look, this model is meant for explaining certain things. It will not be as efficient in forecasting. Definitely beyond not beyond one period, two period, etc., etc. But bluntly, I will not say no. This is bullshit. Don't do it, right? So I'm hesitating because I have my own ego that I can do everything. He thinks that he bought one thing who can solve everything. This is lack of understanding, lack of clarity about the objective. What do we want to do? That's where people fail, right? All other things would fall in place. And even if they are not in place, if objective is very, very clear, people can figure out what are the trade-offs. So I do not have a scaled operation at the moment. I don't have money to put that scaled operation in place. Then maybe I cannot get a refresh every real time, maybe once a month, maybe once a quarter, maybe once a 6 months. And then what is the trade-off along with that? That we can talk and then figure that out. But that clarity about the objective, and that's most important.
No, to be honest, I think, Sanjay, we used to do that, right? We used to ask our customers or clients to write your business objective in plain English on the whiteboard, and those were so hard conversations because you were asking them to write the business problem or a business outcome you're trying to achieve, not what data you want, what model you build, and what output you're getting. We're talking about business outcome that you want to achieve. Full stop. And that was so hard for people to even fathom. Even today, I get that all the time when people talk about it and say, "Well, but what are you trying to achieve, by the way?" "Oh no, I want to build a model." "Oh, okay, that's a different story." So that's the way it should be, anyways. Thank you very much, guys. Let me go quickly to the question and answers questions that we've got from the audience, and take those questions and take it to the next level. Give me a minute, and I'll be back. Okay, so I've got two questions. Let's take those. One is from Avina Sahu. Hi, Avina, how are you? And says machine learning is a process, more of an automation process, which is used for predictive analytics. There are other processes. There are other processes other than ML. Is also used for predictive analytics in some way. Predictive analytics is a superset. Similarly, ML does more than only predictive analytics. In the sense, ML is a superset. I got confused. Is that what he's saying, that there's an intersection between predictive analytics and machine learning, and there are in both the cases, one is a superset of the other? Um, but
I
he
think
says,
I think I think he is reaffirming what we have been discussing here.
Mhm.
Yes, we do agree. There's an overlap between all these things. Predictive is one, then explanatory another one, right? And then there's another dimension we discuss. Supervised, unsupervised, etc., etc. So they all interplay with each other. That's correct.
Okay. Let's look at the next question or comment, whatever it is. Ashish Chaudhary. Hi, Ashish. How are you? Isn't predictive analytics outdated if we follow the process that it starts from statistical modeling and then to PA and then ML and AI? So someone said AI on this in the session, and also Do we need to focus more on ML in order to upskill ourselves and do better in the job? Who wants to take that, Mamta?
Sure, yeah. See, first of all, Ashish, predictive analytics, when you're saying that, going from statistical to predictive analytics, then ML, and then AI, there is a reason why this sequence, right? When the humanity started, it did not start with cooking on a gas stove, right? We were doing cooking with wood and fire and all of that. So that's how it all started in the data science world as well. You started with statistical models, you understood how you can use maths to solve business problems, right? Then you started understanding that, oh, this can also help me in predicting things. Then you realize that given there is so much of data, the cloud is helping you do so much of calculations, right? There is the machines have the capacity to do so much of calculations, etc. So you started doing machine learning, if you know, actually started way back in 1960s, right? But why only in last 10 years did it gain so much of it became a part of so many discussions, we started using it. That is only because now machines have the capability to do it. And then AI, I mean, again, Shailendra and Eric would kill me for this because they don't want me to use this word here, but then see, AI is even a broader discipline, right? ML is a subset of AI because AI could also be, even your robotic process automation is AI. You're just teaching the machine to do XYZ, exact simple steps which you're supposed to do. All of that is AI, right? So if you're teaching the machine to build a model and automate it and all of that, that is AI, right? Of course, you need to do all of these things to stay relevant, but at the same time, if you don't understand what goes behind it, then again it's junk in junk out, because you only know that you need to build up a machine learning model and convert that into an automated machine which you're calling as AI, but you don't know why you built the model, what was there in the model, was the model correct or not. So it is important for any data scientist to go through the entire process in order to be successful, is my take.
Eric?
Well, the question is as written is a little hard to decipher, but why don't I pick on the AI thing a little bit more? Uh, I think that sure there are super. You can always say there's a broader class of things that includes machine learning in it, and you could say you could define predictive analytics as a little bit more of the business project that couches it if you want. Although I don't see that in general um, as a definition. But the problem with whatever kind of field you're trying to define, if you use the word intelligent in the name of the field, then you will fail, because intelligence is subjective and engineering cannot pursue a subjective goal. Um, and there's no definition that satisfies, right? I mean, there's that paradox that once something's been achieved by a computer, it's automatically mundane. It loses its charm. It doesn't seem so intelligent after all. So AI, by definition, is things that we haven't got the computer to do yet, and therefore it's unachievable, because once a computer does it, it doesn't count as AI anymore, right? So basically you're overselling by using the term intelligence. You're implying capabilities that we either have or reason to believe that we're headed on trajectory that we'll have on some time horizon, but we're not headed in that direction in a way that in the spirit of the word intelligent. There's no evidence. It's no different than when Alan Turing first philosophized about what would it mean to use the word intelligent for a machine back around 1950. Nothing's changed. There's no technical process progress that makes the word any more appropriate than it was back then. So I think AI is a great concept for science fiction and philosophy, and I don't mean that facetiously. I love philosophy and science fiction with those concepts. But if we're talking about actual engineering, something that we're really doing in the real world, what do the kids call it in real life? IRL. The word intelligence is only going to harm any clarification about what we're trying to do.
Sanjay?
Ashish, in your question, the most important thing, and which gets a counter question, is the last part. Better in the job. What's the job? First, like we were talking about business, what's the objective? So here, what's the job? If your job is of a, say, data science scientist slash machine learning engineer, obviously you have to be the best in machine learning. But suppose you are a merchandising manager in a retail, understand your business and understand what all these components can do for you, right? So I could not get that question very clearly because I do not know where you are, right? But if you are focusing on a business, understand the business, improve your understanding of all these components, including the new toys which will come in the market in the name of AI in near future, right? Don't fight on the semantics, just understand what it can do, and more than that, understand what it cannot do. And if that requires a little bit of training, retraining, do it. But if you are focusing on one of these areas, then obviously that's a completely different ballgame.
Okay. Very quickly, before I go to the last question, Eric, you have authored this book, Predictive Analytics. Two questions around that. Why didn't you name it machine learning? And and tell us more about the book as well.
Sure. So the full title of the book is sort of an informal definition of the field: predictive analytics, the power to predict who will click, buy, lie, or die. And this has been a bestseller, also used at universities. Hundreds of universities have adopted it as a textbook, but it's not written like a textbook. It's accessible to any reader. So it's an introduction that's meant for business side people and newcomers. And as a former academic, it's conceptually complete, but it's very much anecdotally driven with examples. Now, I was in machine learning as a grad student starting from the year 91. And the first time I taught the graduate level machine learning course was 1997 at Columbia University. And then as of 2003, I became an independent consultant applying machine learning for business applications. But in 2003, it became very clear very quickly I better not use the term machine learning, because boy, did that sound arcane and esoteric, and nobody was going to buy it. The term of art at the time in the business world outside of academics was data mining. But
Oh,
I
yeah.
saw the writing on the wall and I thought, nah, that's a really fuzzy term. And people were just starting to use the term predictive analytics. So that's the name of the conference, Predictive Analytics World, the conference series that I founded. And yeah, the title of the book, that the most recent edition in 2016. Um, and much to my pleasure, the term machine learning that was really just for research and development and academics has now become a mainstream term. In the meanwhile, I also taught the AI course at Columbia, and much to my dismay, that's also become the term.
Okay. Very, very quickly, I will take the final question. And I'm taking this question just because of the word AI. So he's saying, this is Avina Sahu. He's saying, I've been to many webinars. I saw many leads are of the same opinion as you, that we are just not in favor of AI, or they don't like people talking AI. However, AI is the most used word in data science profession. Even when we meet for work or proposal, we meet client for work or proposal, we often use AI term in conversation and PowerPoint presentations. Very common terms are AI driven data exploration, AI driven modeling, AI driven insights. Everything is AI driven. Do you think AI term is misused or overused? Sanjay?
Yes.
Uh, this is an enigma. So I thought that I should create my own definition, honestly speaking, right? And so to me, AI is several components which are coming together, and then we can call it AI if we want to. That intelligent part is always a big question mark, which Eric pointed out, right? And it will always be a challenge to address that. But any system which can sense, that is, get the data or information, right? Process that information out of, use this, the insight out of this or estimates out of this, and take decisions, watch the outcome of those decisions and flow it back into this process. If you have all of those components, maybe it is sort of AI, whole of it. But the components are also part of AI, right? So if you are doing a data process and setting up, data engineering pipelines, and you are saying, I'm doing AI, Maybe to some extent, yes. I mean, you are not treating full body, but you are treating a toenail. So, from that extent, but I try to encapsulate AI in this term, and I do not like to fight with people because people have their own opinion. But I'll defer this to Eric and Mamta.
Eric, what do you think?
Well, I think that the in the full question that Avina, the question asker, most of the uses of AI there sound like it was just being used as a synonym for machine learning. And I
Yep.
think we can call it, we can call it quixotic computing. We can call it AI. It rose by any other name. If you want to use, instead of calling it machine learning, you want to call it AI instead. Uh, the good news is you're not breaking any international laws. The last time I checked, and we can use words. We call these things smartphones without any grandiose implication of how intelligent or smart these phones actually are. Um, just I think it's important to be aware that that's not how AI is generally agreed to be defined, and that it's thrown around. There's artificial general intelligence, which is the full guacamole, and there's narrow, which is typical machine learning, but people aren't differentiating, and they're throwing the term around with um, hyperbolic intent.
Mamta, before we close.
Yeah. No, totally. See, AI word is certainly overused, misused, used by anyone who doesn't understand it, used by people who understand but are aware that it is cool to use it. So, we are also using AI insights with global leader thoughts today as our title, right? So,
Yep.
you know, it is wise to use the term if you understand it well and you know why you're using it, like we're doing for this program, right? But just generally using it without really having any thought to it, I feel that we should not do that, right? It is a shiny toy. Everyone wants to use it. It's a sales pitch. Clients gets excited. They see that their competitors are doing it, so they want to do it. As data scientists, our responsibility is to make them understand, right? As and more so as consultants, it is the onus is on our shoulders to make sure that the clients are using the right components of AI to make or to add value to the business, is what I would say.
Good stuff.
Yeah.
Good stuff. Thank you very much. Those were the questions, and thank you very much for your time. And I know, Eric, it's 9:30, more than 9:30 at where you are at the moment, and the day is just beginning for you guys. Sanjay and Mamta, thank you very much for your time. It was a pleasure having you on the show, and I think it was a great conversation.
Thank you
Thank
so
you.
Yeah.
much.
Thanks for having me. Thanks to both of you. Great meeting the two of you. And Shalendra, was great being on here. So everyone, wish me sweet dreams.
Bye. Take care.
Thank you so much. Bye bye.
Thanks. Bye. So, guys, that was Sanjay, Mamta, and Eric from different parts of the world discussing predictive analytics and machine learning. Before you go, as I said, a giveaway. Here is the link to Link Plus AI, which is the app available for you free, and you can use the app to understand how your LinkedIn profile actually looks like. It projects to the world and looks like, and also you use the app. It is absolutely free. Uses machine learning and is available on both iOS and Google Play, Android. So you can use it and also share it with your friends. It's absolutely free. All you need to do is use the invite code 611074. It's only for selected few. It's not for everyone. So please use the code and use the app and see how you actually project to the world and other things about your LinkedIn profile. And I think very intriguing it was when I used it. So have a look at that and we'll take it from there. So guys, thank you very much. It was a pleasure having you on the watching, pleasure having these guests on the show, and it was a pleasure for you guys to watch the show. Thank you very much. Please like this show, like, love, whatever you want to do, whichever platform you're watching this on, LinkedIn, Twitter, Facebook, YouTube, wherever you're watching this from. on just press the like button, press the love button, retweet, share with as many people as possible, so that more and more people can learn on the basic fundamental concepts of predictive analytics and machine learning, as we talked about. So thank you very much, and I'll see you very soon. Bye now, and take care.